Good morning. Thank you for coming. I'm sure you all had fun at the party last night. Hey. I couldn't make it to Walshy's talk because I was still in bed, but I'm here now. Anyway, every single time that I've come to a conference, we've had technical difficulties, and I apologize. So we're 1 minute behind. It's the joy of using a Mac. We actually do that sometimes. Not a lot of folks here. Last day in the conference. The people that are here, are you Windows Phone people? Yes. Okay. So do you have apps today? Do you have app issues? Are you here because you want to just learn random stuff, or do you have specific problems? Random stuff. All right, cool. It's good if you don't have problems. Life's better. What the heck is performance? I've given this talk a couple times. So if you went to Mix this year, or you watched Mix online, this is going to be really similar. The difference is the slides say Tech Ed. So hopefully you didn't go to Mix. Anyway, when you look at what you can do in Windows Phone, one of the places where I've been really focusing with a lot of people recently is startup time. So I'm going to talk a little bit about that. Really, all this other stuff, of course, I'll cover if you're new to it. If you're not, it's a good refresher, I hope. One thing that I do is I walk around with my phone all the time. I'm one of those people that, I'm walking on the street like this, and I run into people. And the reason is because I'm testing my app. And a lot of people have published stuff into the marketplace just blindly. They run it in the emulator, they hit publish, it gets approved, and then they find out that there's huge issues with network perf, with latency. And I think one of the biggest suggestions I've told people is write your app, but don't think you're done until you've actually disconnected from the emulator, you've walked around, you've sent it to friends. It seems like really silly, basic advice, but a lot of people have gotten burned by this. Of course, in the professional world, we'd never do that. Some of the other stuff, network connectivity, of course, is kind of a weird thing. A lot of people don't even think about perf, and there's actually a couple ways. I'm not going to show you because it takes like 10 minutes to set up, but if you've ever used Fiddler, Fiddler is a nice tool on the PC. It lets you track all your web requests, and it actually lets you also throttle connections. So you can kind of create a 3G-like speed. You can kind of mess up your network a little bit. And so if you just Bing for Fiddler or Google for Fiddler in Windows Phone, you'll hopefully find a tip on how to get going with that, because it's kind of a nice way to not have to disconnect but still get that experience. Looking at startup time, this is all the exciting things that are packaged inside your app. We call it a Zap. Apple calls it an IPA. Android doesn't have such a cool name. But really, it's just a zip file, of course, that has all of your DLLs, any of the assets you want to have downloaded. And in the marketplace, you'll see that when you have an app to offer, there's a Zap file. The client downloads it, and then we actually explode it on the device. So we don't, at runtime, actually extract that zip. We just do it one time. And then on the machine, you'll see, of course, in some folder based on your app ID, you'll have your main DLL, all the reference assemblies you have that are packaged with your app, and then, of course, any other content. Inside the ROM, you'll have Microsoft Phone DLL, the System DLL. These are not inside your apps directory. There's just a single copy for the whole phone. But anything like the toolkit or the SDK controls, those are inside your app. And what's interesting is I've kind of colored things a little bit, trying to explain in craziness what happens. When we go ahead and start up an app, we first read the myapp.dll, and we'll read the entire app once to make sure it's an authentic signed assembly. So we read the entire thing. If it's 10 megabytes, we are reading 10 megabytes off of the store, which is kind of slow. If your main app is 150K, that's really quick, and things will go a little bit smoother. Immediately after reading it, we actually have to read it once again into the CLR. And so the first time is verifying it. The second time is actually throwing it into the CLR and loading it up. So again, if it's 10 megabytes, that's a huge fail. Inside an app, I have an embedded resource just kind of chilling here. This might be some image you want to load up. And the trouble with embedded resource is, again, that's part of that DLL. So if you have 400K of images, you're going to find that, again, your startup time actually hurts from that. And the bug we have in Visual Studio, if you just add a graphic to your project, by default, it's marked as resource and not content. So by default, we give you the really horrible performance instead of the good performance. Kind of sucks. We're going to fix it someday. But the way to do that is you just go into Visual Studio, you touch your image, you hit Properties, Change it to be content instead of resource. I'll show you that in VS here in a bit. Other things that we do, we parse the entire app.xaml. So at startup time, if you have just tons and tons of styles, your business might dictate that you have to brand it, and that's great, but realize that that's going to affect your startup time a little bit. We'll also parse, of course, your main page.xaml, but we won't parse any other pages or XAML until they're needed. In my project, I've also referenced probably like the pivot control. So we'll, of course, read the Microsoft controls DLL. Same thing. First, we verify it. Then we load in the whole thing. But if you've kind of organized your app the right way, you can move your content out. You can move helper assemblies out. You can move pages you don't use into other assemblies. And often you'll see that like your startup time will get decreased. It'll just get halved if you move stuff out. So I guess that's it for startup time and just random tips there. When we are looking at Windows Phone 7, if you've been with us for a while, how many of you had apps that were really slow in 7.0? Yeah, you've all seen it. You like flick on the app, and it kind of gets kind of stuttery. It judders. You'll flick something up. It might look good for a second, and then you put your finger down, and it keeps scrolling up. And that just looks horrible. Other phones out there don't do that. And the reason for that is that almost everything in Silverlight is done in the UI thread. So whether it's touch input, handling a manipulation, a flick, doing a network request, a lot of this stuff happens on the UI thread. And that's great, but of course, if we're in the process of parsing the XAML, we're updating data binding, crazy stuff happens, well, all that's happening during your touch. So if you were to flick again, we don't actually process it maybe for 200 milliseconds. And anything over about 100 milliseconds is human perceptible, which means people get angry. So we knew this wasn't great, but it was a nice change, actually. It was improved from what Silverlight Desktop did. But for Mango, we went back, and we added one more thread. So now we have 4 awesome threads. We have the touch thread, which as a developer, you can't interact with at all. It's all just in native code. We wrote it in C++. We have the compositor thread, which is where we're doing all the graphics animations. So if you have some really primitive animations, you have something fading in, or you have it translating on the screen, all that happens in the compositor thread, so it's going to be smooth no matter what's happening. And then we have the UI thread. So we've kind of dictated that a lot of these things we can move off to other threads as possible, but the UI thread remains kind of the big kahuna. So all of the rasterization, any graphic, the first time we're ready to show it, we actually rasterize it inside the UI thread. It's important to know if you're doing game development. All the data binding happens there, the layout happens there, and any operating system calls mostly happen there with the exception of touch. So the UI thread is the one place where inside your app you'll find the biggest bang for your buck if you're trying to optimize. Background thread, if you're smart, a good developer, you have a job, you'll use this guy. And so this is where you can do parsing of data, you can do a lot of network requests. And in Mango, if you start off like a web client call from a background thread, it'll come back on the background thread. That's a change from 7.0, but it gives better perf to apps. How many people have seen these cool little numbers? A couple guys. Oh, okay. You get to learn about them again. These are the performance counters. If you have a debugger attached and you've used the default project, these are what pop up on the phone. And they're kind of hard to read. They're small, but super important. The very first one up there is the render thread. That's basically how fast the graphics engine is able to handle whatever it's doing. So these are independent animations. This is what's going to give you really fluid like fades, really fluid transitions. All that happens on the render thread. And in this example, we're at 13 frames a second. It's red because that's horrible. Obviously, 60 frames a second is the best we could hopefully achieve. And 60 frames a second is easy if you've kind of structured your app the right way. Second one's the UI thread. Again, that's where all the magic happens. And if in a perfect world, 60 would be cool, but often it's going to be 30, 40. That's okay if it's just brief, but if you can get up to 50, that's really good. If you ever do game development and you have like a render, I think it's called render composite target, I don't know. There's a property that gets called every single time that we tick if you want. And so if you want to do like a game and you're trying to do your own graphics animations, if you use those properties, it's going to significantly drop this down because we're going to call you every single time we go to paint a frame. So just beware that if you're doing your own crazy game stuff, you probably won't get 60. The next numbers, you can ignore these. Game developers might care about texture memory, surface counter, not too exciting. It's not until this one down here, the fill rate, that actually is pretty interesting. The fill rate basically says how many pixels are we drawing, how many screens of pixels. So if it's 1.0, you're probably looking at something, think of a photo. There's an entire screen of pixels. There's 480 by 800 pixels being drawn. Pretty simple, so your fill count is 1.0. That's great, it's easy. We can easily paint one entire screen, no worries. In this example here, we're up to 2.7. This is kind of a little bit around our threshold of being scared. If you're over 2.5, if you imagine having maybe, you have one big picture on the screen, behind it maybe you have another picture you're trying to fade in, that would get you up to 2. But once you're over 2.5, we can no longer actually reliably have the graphics processor doing this cool compositing. So after 2.5, we have to go fall back to the CPU, which means it's going to affect the touch input speed, it's going to affect how fast things are processing, it's going to slow everything down. So definitely check your fill rate. It's actually one of the biggest indicators in performance. And tons of people in their apps have 3, 5, 6 for a fill rate, and you can really feel it. If you see like a panorama app, there's tons of them. You kind of flick on them, and they kind of judder along. And on those, you'll often see it, they're up at like 4. How to fix that? There's lots of stuff. We'll look here in a demo in a second and how to go about that. And of course, the craziest thing that we do is the layout system. Layout is the magic in Silverlight, and we brought it to the phone. And the idea of course, the layout system is you drop things in a stack panel, you drop them in a grid, things resize accordingly. Someone has to do that work. Thankfully, as a developer, it's not you guys. But of course, it's our layout system, and it's kind of built to the worst things in computer science. So it's recursion. We will recurse over objects. We go through the visual tree. We get to a node, and we say, hey, is your node dirty right now? If the answer is yes, something's changed, then we'll go through, we'll completely measure it, figure out how the spacing works, then we'll ask it to arrange itself. Okay, that sounds good. At that point, that node is a little bit cleaned up. We'll move into the next one. It's this big iterative and recursive process that happens. The trouble is, if you're doing like per frame callbacks, we'll actually do a full pass. You have a callback, something might get dirty. We'll do another layout pass in a single frame. And so that just completely kills perf. It's horrible. You don't really need to understand too much about this, except realize that every single time you change a property, we're going to go and do layout again. So if you have an image that you've thrown like in a list, and the image hasn't downloaded yet, its size is going to be 0, 0. And then as soon as the download happens, it's going to pop to the right size. So we'll do an entire layout pass of maybe 10 items in the list. They'll fit perfectly. We've spent the CPU time to do that. And then one image comes in. Okay, that sounds nice. The image gets resized. The tree gets invalidated. We're going to go ahead and relay that out. So the first item changed. The other 9 items haven't. Little CPU cost. In the middle of this, 2 more web requests complete. 2 more images pop in. It's going to mean 2 more full layout passes. And it just kind of recurses all the way down. Kills perf. There's ways to mitigate that. If you're throwing images into like a list and your designers tell you it's hard-coded, they're 60 pixels wide, 60 pixels tall, just hard-code it right inside the image instead of letting layout do it, because then it just, no matter what happens, it'll never pop. That's all my slides. It's that quick, it's that easy. Thanks for coming today. Oh, but I've got a demo first, so let me go ahead and open that up. Ooh, I've never used that view. That's like the marketing view for Windows. There we go. So this is Visual Studio. We've all used it. It's awesome. It doesn't really work too well at this resolution, so I apologize. 760 by whatever it is, 1024 by 768. What I have here is just a really simple project. It's the same one that I used at Mix, changed just a little bit. The basic project's there. I have some data in it. There's some templates. I have some additional controls, and in general, it's pretty small. Something I can point out is, of course, these images I was talking about. So background.png and application-icon.png. Down here, they're all marked as content. Content's good. Again, it means it's not included in your app. It's just included in your Zap. And you do have to change that. If I go ahead and I add an image right now, it'll default to resource. It sucks if you don't notice it. So inside here, yeah, this resolution's scary. So I'm a developer. I have no design skills. So I've decided I'm going to use Panorama, because Panorama is what everyone uses. It gives you that nice big text. It says something big that you can't read. There's some headers. You know, okay, it's my first stab at an app. Let's see how it runs. All right. And I tell everybody this, but my PIN is 2222. So if you ever get a hold of my phone, you can do cool things. It's too early for jokes. Sorry. These are called live tiles. It's a great part of Windows Phone. Something iPhone doesn't have. There we go. That was close. This is a splash screen. It's very exciting. Now, something to notice is there's actually an app bar down there. The splash screen was so slow at loading. There's so much happening in the app that it was kind of craziness. Oh, there we go. All right, so this is my awesome, awesome app. The performance counters up here are like impossible to see. I can kind of read them off. My compositor thread right now is at 51 frames. At the second one, my UI thread is at 51 frames. That's pretty good, actually. And this is better than this same exact app performed in 7.0. I'm going to show you how it sucks, though. So, I'm manipulating. This is actually pretty good in terms of performance. The UI threads dropped down a little bit, but we're still at 45 frames on the compositor. On Mango, this is looking pretty good. Now I'm going to flick, though. Where'd it go? There it goes. OK. So that's blanking. We've all seen it. Blanking is horrible. This is a virtualized list control, which means, I don't know, I have all these books in here, and the pictures aren't books, but you know, whatever. All right, it's blanked. So there's maybe 100 books, and we'll render about 3 screens worth. So in this, currently we have, I guess, 4 items that are obviously on the screen. There's going to be 8 more items which are off screen, and that's part of how a virtualizing stack panel works. But once you're past those 3 screens, we have to actually create those, which means as you flick, we're going to create these items on the UI thread. Thankfully in Mango, it's still kind of a smooth experience there, but there are issues. You know, it has this horrible blanking experience. If you use an iPhone, iPhone doesn't do this. What they do is they actually sacrifice frame rate in order to show you unrealized items. So on an iPhone, you'll see it sometimes, you'll flick and it's really jerky, and it just goes really slow, but your items are always there. The trade-off we made is we keep the frame rate high, even if you don't always see your items. So it's kind of personal opinion. We chose one way. Just realize that the only way to really fix this is to simplify. So we'll get there in a second. Another thing to point out is the fill count here. I'm at 2.4 over here. So that's decent. It's not too horrible. We can, of course, render these items. And it's all done on the GPU. So let's make some changes. First thing I want to show you is how you can definitely always solve blanking. Whew, can almost see the screen. All right, so here's my panorama control. And in there is the list boxes on the first page. And I can go ahead and change the actual panel for this. Property name is called items panel. And by default, it's virtualizing stack panel. But if you want to make sure that something never blanks, you say, OK, let's just kill the virtualization. Oops, items panel template. So I have a stack panel in there now. I'm going to switch over one more time. To something. All right. I'm going to go ahead and run this and watch it very slowly start up. 1, 1,000, 2, 1,000. You can hear the crickets. All right, so we are now in. Took a long time, but if I go here and scroll, it never blanks. And that's because we completely sacrificed effectively runtime speed to have this experience instead. It means at startup time, we rendered every single one of these items. It looks good. It means it touches really good. But the downfall is, of course, startup time is horrible. So it's a trade-off you can make. In one of the apps I have in the marketplace, I actually don't use virtualization in almost any of the app. I instead show people these items. I kind of trick them into thinking that it's loading. They'll see a little loading screen, and behind it, I'm showing all the items. And that's the trade-off I made because I never wanted it to blank. But of course, we can do better than this. No one wants to have just an unvirtualized list. And it's a horrible answer of something to fix. So let's make some perf improvements. First of all, I'm not a fan of Panorama. People that listen to me on Twitter know I'm not a fan of Panorama. It's because I wrote Pivot. So I use Pivot. I can be honest about that. So I, of course, want to use my creation. Ooh. I didn't write that part. Yeah. If anyone's listening to the recording, I'm sorry. We just saw a Visual Studio crash. It's a key part of every Microsoft demo. I should note, I'm actually using the same tools that are public right now. These are some older ones. So hopefully it's fixed. All right. Search and replace Panorama with Pivot. It's that easy. And things are looking a little better. Now, of course, we still have a background image. It's completely legit from like a UX standpoint to have a background with a pivot. But I think that background doesn't really help my app at all. So it's gone. And that little thing right there will actually improve performance quite a bit because the fill rate's going to go from 2.5 to 1.5. It's a pretty good win. I don't need this virtualization template anymore. And so, okay, it's kind of decent. We now have a lot more visual space actually to see the list. Of course, there's situations where you want Panorama, but often Pivot shows you a lot more data. Instead of just kind of guessing what's going on, though, we actually have these nice little performance tools now in Mango. And I was recently talking to someone on a podcast a couple days ago, and he had no clue about this, which means you guys may not know either. It's hidden away in the debug menu. It's different than where you'd find a lot of the Visual Studio perf tools. But you just come in here and you say, start performance analysis, you'd think. But it's actually start Windows Phone performance analysis. I didn't design this, but I know how to use it. There's these exciting options. You can either go for execution, which is going to be basic, what's our perf on the app, or the second choice is memory. Let's go for execution. There's some crazy options that I guess we don't really need to change because the defaults hopefully are good. And right now it says emulator. So down here there's this big warning saying, hey, you're trying to use the emulator. It's probably not a good idea because it's nothing like your app. So I'd rather have it do this on my device. It's happier now. It's saying you should do release because release is more similar to how you have to publish in the marketplace. If you actually publish a debug app, the marketplace won't even approve it. So let's launch the app. Ooh. That's kind of cool. It's the same project, isn't it? We'll go for this one. All right. Let me see if it builds. Build succeeded. Okay, whatever. Start Windows Phone performance analysis, device, release, launch. Key thing to keep in, okay. Rebuild all? Huh. Okay. Yeah, this is embarrassing. It's almost like it can't build the toolkit. Build succeeded, it says. I think it's lying. Okay. I work on the toolkit too. That's kind of cool. All right, so the key thing to keep in mind, if this ever starts, is that time is precious. So like right now, I can see the startup screen. Every little like second, it's doing tons and tons of instrumentation. And so, of course, you can sit here for 10 minutes, but then it's going to take hours for it to be calculated and computed. I'm just flicking on the screen real quick. I'm going to hit the back button. And hopefully this realizes that I'm done. There we go. Basically, it copies a file that it was instrumenting with off the phone over here, and then it analyzes it. And this can take a while. Thankfully, it's a Core i7. It's kind of quick. The joke I always have for people is, why are there 2 progress bars on this screen? There's one down at the bottom, and there's like this ring. Somebody designed that, definitely a coder. I'm sure there will be something. They don't tell me anything. Yeah, this is fun. Yeah, this is kind of scary. Maybe it's really broken. Oh, sweet. All right. So what we can see here is my startup time is horrible. There's a kind of a timeline view, and it's actually 10.5 seconds before we're rendering a single frame. That's going to actually not get approved in the marketplace. You're allowed 5 seconds for something to appear and 10 seconds for your app to be responsive to input. This here would just kind of be failed. And what you can see is once we do start having frames, you get a frame rate. So 60 is great. You can see that's the tops. Sometimes it drops down. You can analyze this to kind of get a high-level idea of what's happening. But of course, what you really want to do is you highlight a region of time that you want to kind of jump into. So I'm going to guess that most of this is just startup time. It's loading assemblies and parsing, but I'll grab just a big chunk to start with. And it's actually giving a ton of little suggestions here for performance warnings. And it kind of makes sense. The first one is saying there's a ton of memory allocation happening at the native side. And that makes sense for me because I'm actually starting up the app. I'm rendering graphics and surfaces. Totally makes sense. So I'm going to disregard that. High CPU usage on the UI thread. It's over 50%. This actually is a problem. Again, the UI thread, at some point it makes sense if you're parsing tons of stuff that you need to do on the UI thread, if there's data binding happening. All that has a place, but it's something to look into because it's just high. These things are exciting. There's moderate thread happening. It's spending time probably in a background thread. These warnings, though, they just don't tell you. They don't tell you on line 20 of this YAML file you've done something wrong. It's up to you as a developer to kind of jump into this and try to really figure out what's happening. So performance warnings are just one place to start. The real trick is diving into the actual analysis. So I have 2 choices right here. I can try to figure out CPU use, or I can actually jump into the individual frames that were rendered. So I'm going to go for the frames. And this shows you for every single frame out there, it shows you exactly what happened. Exactly when did it start, how long was that frame around before the next one ticked, and also, of course, what's all the values for it. Again, it seems kind of nice, but it's not really a ton of data. I can see it right here. There's something crazy happening, 74% CPU usage. So you can actually jump into the subsection here, pick a couple different things. First one I'm just going to look at to show the complexity of apps is the visual tree frame. So right here, this is at runtime. It's actually a capture in one point in time of the entire visual tree. And there are hundreds of items here. This is really common. It's the same in Silverlight. You add one little button, and if you don't think about it, there's 10 different controls in there. There's different elements. There's borders. There's grids. And, of course, they have a place, but every single item is going to slow down performance just slightly. So the more simple that you can make your templates, the quicker things will be. But what I have here is, of course, OK, here's the performance progress bar. Kind of need to have that around. I need to keep that. Here's the panorama control. And panorama is a really, really visually rich control. This is obviously not the version of the app I had, because I had a pivot in that one. But it's good to look at. Inside here, At some point, I'll find the rating control. Here we go. So every single item in my list box, by default, a list box item has a border. Inside there's like the content presenter and all this stuff. There's an image, which is the picture of like the book. There's the name of the book, the author. Those are simple. It's just 3 little visual things. It's pretty cool, pretty simple. It's going to render really quickly. Trouble is, this rating control, it's kind of heavy. If I expand this out, this rating control is actually built up of a ton of stuff. So a single rating control, there's a grid, a border, items presenter, stack panel, and then a ton of rating item controls. And this is the Desktop Silverlight Toolkit's rating control. It was written by a pretty cool dev. His name's Jaffer. He's smart, but he built this control for the desktop, not for the phone. And so on the desktop, you can do beautiful things. You can do the most complicated, beautiful templates ever. You can have the best rating control in the world. But for the phone, that means, look at this. Every single item is a rating item with a grid and a border, a path, a clipper. Inside there is a content presenter. Like, this is just crazy. Every single rating control is just, I don't know, I did the math once. It was like 200 items. So if you imagine a screen, you're looking at almost 1,000 visual items just showing the rating control. Of course, for my business, I probably don't want to drop the rating control. The designer said I have to have it. So what are some alternatives? It seems like this is probably a good place for me to investigate here in a second, because the rating control is obviously a really big part of this. But some of the other things to look at, I can jump into the function tree. And this will show you at this exact time how many samples there were in different methods. And this might help you kind of track down perf issues if you're like blocking threads. Again, here you can see there's just lots of threads actually waiting. This is totally normal. Threads sit there, they wait, they'll spin. Nothing kind of scares me just looking at this data. Other things you can look at are whether we're actually updating our surfaces. So this is communication that happens between the rasterizer in the UI thread and the compositor. If you see a ton of stuff in here, you might want to look at it just to see, does it make sense? In this case, we've updated pretty much all the list box items. That's part of that layout system. I think it's probably by design. We have to at some point throw these items into the surface, into the graphics processor using a surface. Makes sense that we'd have all these items because we have the current screen plus the next 2, all kind of being thrown over the GPU. Element types is another one. This will tell you can kind of do an all-up view of how many times were single controls updated. It's actually really useful information because before you just couldn't get a hold of this data in the tools at all. Again, nothing really to jump into. It's something where if you have a specific issue, if a certain part of your app feels slow, it's a great way to jump in and someone says 4 seconds in, it gets really choppy. Okay, so kind of highlight that 4 seconds and figure it out. But in a talk like this, I don't have any great insights. You just have to kind of sit there with the data and see what happens. So the other kind of data I wanted to show you, of course, is memory management. In 7.0, there weren't too many ways to manage your memory. Oh, it's going to yell at me. Try this one more time. All right, it's collecting data. I have a splash screen. Startup time is still atrocious. Hope he's taking notes for all of us. All right, so I'm kind of started up. It's starting to show items. I can go back, and hopefully it's quicker this time. I'm going to cross my fingers. I'm losing hope. Couple progress bars. So in Windows Phone 7, there's no way to instrument for memory at all. There's a way to pull and see what the current use was for your single process, what your peak was, and what the available memory on the device is. Thankfully, those were not very good ways of doing this, and the profile at least should tell us what's being allocated. And let's actually jump into both the managed stack of objects and see what the GC is dealing with. I didn't write this tool, by the way, just for the record. There might be like a thread.sleep in here for 30 seconds.
They use the same tool. They do this analysis when you submit your apps to Marketplace. Do they use the same tool?
We actually don't. The testers that are actually doing the work on Marketplace apps, they don't actually instrument your app like this. They have almost like a stopwatch time. So when they start up the app, it'll actually kill the app if it doesn't meet the certain restrictions, and then they can really easily catch the exact time. But all right, so here we go. Of course, we're starting up an app. It makes total sense that the memory usage should be going up. Some of the things it'll show you is both when you load images. So these are images coming from inside the app, and then actual garbage collection events. You can see when those happen. In 7.0, a lot of people would call gc.collect all the time to try to kind of be more efficient with memory use. But there's a generational garbage collector in Mango. So delete that code. It's no longer important. But drag over here, though. OK, nothing too bad's happening. It's kind of a consistent number. There's a little bit more data loaded in here. Again, same thing. You can highlight a section. Oh, that's great. Analysis may take time. And in here, you can actually, oh, geez. I have horrible tools installed today. So if you have a good tools install, you can either see a crash, much like this, or you can see the heap. It's just one of those days. So the data is actually stored. If I go ahead and open this directory up, there are these SAP files. And so you can do this analysis later. You can actually do this with like every build and try to do comparisons. Some people have even written tools to work with it. So yeah, the data is stored right in the directory. It's pretty nice. All right, so I'm going to pretend that we've shown you that beautiful memory profiler, which doesn't work here. I swear we've tested it. I might have something crazy happening on this machine. But I want to jump into the app and actually try to make some quick improvements. So again, the first thing, which we did earlier, was pivot to panorama. Whew. Okay. You know, the one thing I can say is it doesn't just crash for you guys. I gave the same talk in New Zealand a couple days ago. It worked great. Something's different here in the water. The real question is, how many times will I try this? All right, panorama into pivot. Cross my fingers. OK, that's one. We've already made that one. Got rid of the background. Now, we haven't looked into this too much, but I have some things in here which, if I had more time, I'd kind of jump into. In one of the pivot items, I actually have an animation. There's a little graphic that's just looping around. I'll run this in the emulator because hopefully it's quicker to start up. You guys don't have to deal with AT&T here, but I like to have my emulator themed with them. It reminds me of pain. So here, this is just some crazy exception. I think this is proof that my app's just completely crazy. So inside here, if I go through the items, all right, there's a picture there, not too exciting. There's a Bing Maps control. Bing Maps is like a super heavy control in terms of performance. So you don't necessarily need to have it around. If you're doing, like in this app, the default view is not the map. So it actually makes sense to hide that control, keep it collapsed until it's actually needed. Because it loads both Bing Maps, it loads the assembly, it starts up and reads all the XAML. It does craziness. Oh boy. My phone just restarted over here. It's great. What you can see here is there's some kind of progress bar type thing just kind of looping around. And that animation, maybe it has a purpose, but it's on a pivot item. And the way that the Silverlight works, we don't actually know what's on the screen or not on the screen when it comes to animations. Because you might be animating properties, you might be animating other things that happen. And so we don't actually turn off animations. Once you start a storyboard, if it's in the visual tree, it's going to continue running. And so here, even when I'm on this stores page, we're doing everything for this animation in the compositor thread. And that little thing, it's happening. You may not think about it, because a lot of people will throw maybe like a rich experience, a rich visualization in a different pivot item. And yes, we're actually continuously running that. So one of the things you can do is you can actually hook up to like a pivot changed, the selection changed event on pivot, and you can turn on and off animations in specific items. And that way you can kind of preserve performance a little bit. So I've shown you a couple of things wrong with this. Let's just pull some code out. I definitely don't need this silly animation. And for now, I'm just going to pull out that Bing Maps control. And then I'll run this. Yeah, of course. There's my Bing Maps key if you want to copy it. All right, so it's starting up. Now here's an interesting thing. I've taken away the animation, and up there, my frame rate is 0. That's horrible. You never want to have 0. The thing here is, if there's no active animations happening, we actually freeze everything. We have no reason to animate right now. So we have completely frozen the compositor. Nothing's being done with the graphics system. It's just sitting there. That means, of course, the frame rate is 0, but it's not a scary 0, because, of course, it came up fine. If I flick, you'll see that it temporarily updates. It's up there to 50 frames, and then it stops again. It's because now there's no more animation happening. So if you're looking at the perf counters, do be aware that sometimes you need to touch the app and interact with it to kind of get an actual accurate number. And some people even put a little animation like that one I had before, if it's lightweight enough, just to keep the numbers always active. But of course, in a shipping app, you wouldn't want to ship that at all. Now on the emulator, of course, it's quick, it's fast. You never see blanking, but we know that on the phone, we had blanking for these images. So in this nice little cheat sheet file I have actually some iterative changes here. So if you actually look in Visual Studio, this rating control that this guy built, there's like, 12 files here. Like, it's crazy. It's super complicated, and we know that we don't want to use it anymore. So what I can actually do is I can meet with my client, ask them, what are your requirements? Do you really need, this super rich control? Rating's kind of a special circumstance, but often you'll see people that use they'll use an opacity mask with images to do some special effects. A lot of little complicated things that you can actually render ahead of time and just store as images in your app. It's one of those things where why should you render something in real time on the phone when instead you could just do it at production time. Have your designers sit in Photoshop doing that. So I'm just going to go ahead and I'm going to replace this entire mess of a rating control. It's that many lines of XAML, it's kind of crazy. I'll zoom in for you. I've actually just replaced it with a content control, which doesn't make sense, but it's a little bit of an improvement. The idea is that I'm going to bind the content of it using a specific template, which is called rating. The template just pops up an image, and then it's going to use a converter for giving me stars. So the idea is that this should actually convert this content control into probably 5 different images representing the rating. So if I run this, it's quicker. On the phone, it's especially quicker. It's visually identical. It's pixel perfect. Basically, there's an image here that says, it's a full star. Down here, we have the empty one. And so for any item, I actually have 5 image controls. There's the wrapping content presenter. There's the wrapping content control. But that means we've gone from hundreds of visual elements down to a couple, and it actually makes a huge difference. If I run this over here, which I won't waste your time with, you actually see that the frame rate, it actually doesn't blank very much at all unless you really flick it hard. So it's pretty good. Now, of course, we can go even simpler. A lot of times you'll see that people have lists of like 4 or 5 items. So if you can think of a perfect world, you're going to have your list box item. You'll have 4 or 5 items. Minimum you want text blocks, images, maybe grids, but you don't want too many visuals kind of packing up. So heck, why don't I just go to a single image instead of 6? It's a big demo, I can do that. So I have an image control here, which is super simple. I'm binding to rating image URI. It's kind of hidden away in my properties, but I've pre-rendered every single possible rating value. Because for me, each of those is about maybe 2K as an image. So, I mean, I can do all the rating values I want for, way little space in terms of download. And it just, hey, it's a simple image. I run it. My phone's rebooting again. Gonna unplug it. Okay, pixel perfect. It looks completely identical. Now, of course, I've kind of cheated here. And if you look at this, I don't have half stars. I didn't care about it. I was being kind of quick and easy. But of course, if I was Netflix, I'd probably have my designers give me quarter stars or half stars. Again, space doesn't matter that much. These templates are super simple. There's the image, text block, image, text block. It's really easy, and on the phone that makes a huge difference. So literally, when you have a virtualized list, when you're scrolling, just think of how much work's being done. Once we get to the end, it's going to create items. It's creating these couple visuals. It's doing the data binding, and that's it. It's just really, really simple. And the beauty of Metro, of course, is simple is actually cool. This is really simple and easy compared to what like an iPhone app might have. Often you'll see gradients in those apps and lots of visual chrome. You'll see lines and borders. That's all extra work that has to happen. If you look here, Metro is pretty simple. Designers can handle it. It's paint by numbers, if you want to call it that. It's kind of an ironic thing is that by having rectangles and really simple shapes and primitives, we're actually getting a more performant experience versus doing all that crazy stuff. So lesson there is kind of simplify. Sounds pretty good. And I have a bunch of other little random notes here that I can step through a couple of them if you want. We have a little bit over 10 minutes left, so I'm also happy to kind of pick and choose any you want to see. Some of the things that I do have as recommendations, of course, are this idea of having a secondary assembly for pages. So inside my app here, I actually have an About page. And if you came to my talk a couple days ago, something like 0.1% of users have ever gone to my About page. Like, nobody cares, but you have to have it. So here's my About page. I have some kind of legal stuff, whatever. If you think about it, every single time the app's starting up, this is part of my Zap. It's part of the actual DLL for my app, and nobody uses it. So it's something that's really easy to pull into a secondary assembly. All you have to do is you add like a new Visual Studio project in here for the phone, and you can just drag your XAML right into it. In my case, I've actually already created this second assembly. So it's called About page. It has the About, and that's about it. So of course I need to hook up to it. You just add a reference to it, to my About page, and then you just have to update your URI to instead look at the component. So in main page, I have a click event, and by default it's just going to views/about.xaml, which is inside my app. I of course want to use a different one. And look, somebody's already typed it for me. So the change here in the URI is it starts out with the assembly name, and then component, which is kind of the magic you might have seen from like WPF, and about.xaml. So this at runtime is actually going to wait until you actually have this call. It's never going to touch the About page assembly. And at that point, it'll load it up and then go to the About page. So it's a little bit of a win in terms of perf. I can go ahead and delete the About page here. So that'll shrink down the size of my DLL. And if the demo gods are with me, which they haven't been so far, come down here and click About. Oh, look, it looks exactly the same. It is exactly the same. Difference is the XAML is coming from somewhere else. And in my app Fourth and Mayor, I have about 6 different assemblies now, which are just completely full of pages. So by default, I don't load a lot of the sub pages, profile pages, place pages. All that comes from other assemblies, and so startup time is all that much quicker. And when you're looking at startup time, if you're looking at an app and it's about half a second to maybe a second, I actually prefer deleting the splash screen image. I'm really tired of seeing apps in the marketplace with the little clock. You've all seen those. It's the default splash screen. If you have a branded experience, your business wants to have a splash screen, that's great. But often if you actually delete it, at startup time, you just have whatever, it's blanked briefly. Your page pops right up, and it actually looks more like the native phone app that way. When you go to the mail app, it doesn't start up, Microsoft Mail. It's just, okay, the mail shows up. So I'd actually recommend trying to not have a splash screen sometimes. It just looks a little bit better in some circumstances. Of course, it's also a trick. If people see a splash screen, they might not notice that, yeah, they waited 1 second because they were looking at your pretty graphic. There's trade-offs there. other things, these are just random one-offs I've shared with people. On my blog, I have a component called static map. If you're using Bing Maps like in a pivot to show a Bing experience, but the person doesn't need to interact with it, you just want to show them a map, there's actually a static API that Bing has. And you give it like the latitude, longitude, you give it some push pins, and it'll really quickly render that image and send it to the client. And so if you want the really basic Bing map, you drop it in a page, and your startup time is really good because we're not loading the Bing Maps control. It's not requesting tiles. It's not doing all that rendering. It just, boom, shows an image. And it's a little trick there. It's another one of those one-offs, but there's all sorts of ways that you can kind of improve perf just by kind of hacking it around a little bit and figuring out what you really want to focus on in terms of perf. So I don't know. This is a lot of random stuff. I'm happy to answer questions. Yep.
With the static map, could you make it render static on, say, they tap on it, like the static one show the real one?
Yeah, that's actually what I do. If you're in Mango, I take you to the Bing Maps task, which actually opens the real map app, which I think is nice. It's a little bit more responsive. And if they're in 7.0, then I take them to, in my case, a separate assembly, just like this about experience, and it's called like map view. And then map view loads the Bing Maps control. And I think loading that the first time probably takes 500 milliseconds. But most users, they touch it, okay, it's loading, that's fine. And then they can completely interact with it at that point. So that's a pretty good kind of way that you can show them a map and still make it interactive if they want to be.
All the apps I see now, even on iPhone stuff, it's got maps. You're always waiting for it to do.
Yeah. A lot of apps I'm seeing now, actually, on iPhone, they have like a 100-pixel map. It's just a little square. It's like, okay, it gives you a hint that there's a real map, and it is the real map, but you touch it to go to the real one. And static maps, they're that much quicker, for sure. Yeah, they support up to 10 push pins with Bing, and they have different styles for all of them. Actually, I'll see if, it's always scary to Bing in a demo, but no, not custom, yeah. Oh, this kind of sounds like it. It's documented in MSDN at some point. Conference Wi-Fi. All right, well, trust me, it works. There's documentation for it, for sure. So can I answer any questions? Yes? Yeah, it jumps, it doubles briefly. It's the cost of transitions. It's actually on my cheat sheet of other things to talk about is, I love the transitions when I can, but I think for a game often you'll have that temporary kind of jump. But the fill rate shouldn't be permanent. It should just be during the transition. If it's permanent, then you might actually have, for some reason, you might have 2 pages that are still in the visual tree somehow when they shouldn't be. So it could be a bug as well. The transitions are actually quicker in Mango. In Mango, if you have a complex page, we'll actually immediately navigate over, and then it'll actually start loading the second page. So it's possible that in that situation, you could actually unload the first one, and in between have a fill rate then of 0, and then the new one comes in, and it wouldn't have the doubling effect. So if you haven't tried the Mango toolkit, give that a try and see if it fixes it. Yeah. Anything else? Yes?
Scrolling with the least virtual stack map, can you have like a hybrid so that when you scroll you get like frames so you know there's something there, and then to render images after?
Yeah. Not by default, but there's a control called, I think, gosh, what is it? Lazy list box or lazy loader list box. And if you just blog for like lazy David Anson, he's a coworker and he's not lazy, but it'll show you his blog. And he actually has that idea of you give it a simple template, it'll render all those. And then when it actually realizes that it stops scrolling, it'll realize the richer items. So that might give some of the experience. In my app, I actually have a lot of pages which are not virtualized, but instead of an image, I'll have just a little grid with like the phone Chrome color, which you'll see in the phone as well. And then once scrolling stops, I'll actually load the images in. And that's kind of a similar idea because images are pretty heavy in terms of perf. Yeah. And I have some components I'll be blogging at some point, which are more specialized, but they do the same experience of only loading images that are on the page once it's stopped scrolling. And it's quicker than virtualization for sure. So, cool. Happy to answer any other questions after this, but thanks for coming here. Appreciate it.